Okay, so let's have some fun with simplifying expressions. We're going to need to start off with some vocabulary, so please write these words down. And by the way, if you really want to be successful in this class, these words are good words to add to some flashcards. I would have a set of flashcards that I would make up, and I would regularly refer back to them. If you do that, you will really have a good grasp of the basics in this class. Let's start off with this important vocabulary word, terms. Terms are just things that are added. And in a minute, I'll give you an example so you can see what I mean. Another important vocabulary word is factor or factors. And in this case, we're going to use it as factor is also a verb, but we're going to use it as a noun. You can factor things, but factors are things that are multiplied. So you can see that it's kind of similar to terms, but they're kind of like brother and sister. They have things in common, but they're also a little different. We're also going to need to know something called polynomials or polynomial. And we'll refer to this much more later, but can't hurt for you to learn about this now. And again, another reason that this would be a good thing to add to a set of flashcards. Polynomial just means many terms. The word the prefix poly indicates more than one of something. And then we have something that we will be saying over and over again in this class, and that's binomial. And binomial simply means two terms, sort of like your bicycle, which has two wheels. Maybe when you were younger you had a tricycle, which has three wheels. And so we'll add that to our list. Trinomial. And that means three terms, just like the tricycle with the three wheels. And again, if I'm going too fast, just pause the video and write this stuff down. Oh, I'm going a little faster than I thought I was going to. There was a couple other things I want to show. I want to show you what two terms looks like. Binomials in this class will look a bit like this, like x plus 3. We'll see binomials that look like that all the time. And binomials can also look like this. I'll show you another example. They can also be like 3x minus 7y. And hopefully you're asking yourself a question right now. Hopefully you're saying, well, what does he mean 3x and minus 7y? He said binomial means two terms. And there's way more than two things here. Yeah, but there's only two things that are well, I call it being added together. The other question you might have is, well, they're not being added, they're being subtracted. Well, if you recall from the subtraction rule, anytime we have things that are added together, subtracted, it's a lot like adding the opposite. So if we just made this into a plus sign, we could make that negative 7y, and it'd be 3x plus a negative 7y. So when I want to identify the two terms I have here, one of them would be 3x, and the other one would be negative 7y. And there are two terms. Now, in a minute, I'll tell you there's a special name for this term 3x and another special name for negative 7y, and there's a reason why it's just a single term, even though there's two things. Okay, so let's get back. I also want to show you with a trinomial. We're going to see a lot of this kind of stuff in this class. Negative 2x squared plus 5x minus 3. This is known as a trinomial, and it's also known as a quadratic expression, and we're going to have a lot to do with this once we hit chapter 5. But I wanted to give you a heads up in advance. This is known as a trinomial because I have three terms, negative 2x squared plus 5x plus negative 3. And let's go ahead and add another vocabulary word to our list, and we'll call it a monomial. Now, you might say to yourself, well, again, something's a little strange here. Polynomial means more than one terms, yet I can have a monomial that's just, and hopefully you guessed it, it's one term. And by the way, where's that mono come from? Well, you might have heard it before if you've ever been to Disneyland or Disney World. The monorail, a single rail train. So monomial means one term. And let's look at a couple examples of what a monomial could look like. A monomial could be something like negative 7x cubed. That's one single term. I'm not adding anything together. All that's going on here is multiplication in exponents. And monomials could also take the form, they could look something like this. 42 x squared y cubed. Perfectly legitimate monomial. A lot of things being multiplied together. These are all factors, but one single term. This is good stuff for you to put on flashcards to remember for later. Or at a bare min, it wouldn't hurt to have a vocabulary list that you keep looking back at over time. Also, one other thing that I want to share with you is with regard to polynomials, there is another concept that we need to talk about. If you have a polynomial that looks like this, 3x squared minus 7x plus 2, we have special names for these numbers that are out in front of the variables. And I'd like you to add this to your vocabulary. The word is called coefficients or coefficient. In this case, we have two, so I'll call them coefficients. You should know that word. We'll be using it in class, and if you hear the word and you don't know what it means, you might miss out on being able to do something. Also, for some strange reason, many times we will refer to this guy on the end as a coefficient as well, especially when we're solving quadratics using the quadratic formula. We'll refer to coefficient A and B and C. And again, here are the coefficients. So let's go ahead and list them so that you can see what exactly I'm talking about. The coefficients here are 3, and I'll use a comma, and negative 7, and 2. The coefficients by definition are the numbers that are in front of the variable, and for some reason when we have a polynomial we refer to that last number, which is also a constant, we refer to that as a coefficient. Let's go ahead and talk a little bit more about some other stuff that you need to know about expressions. By the way, all of these things that I just said relate to expressions. You'll notice that the title of this slide is called Simplifying Expressions. Well, it turns out that expressions can only be simplified. One common mistake math students make is that they try to solve expressions, but expressions really need to be simplified. And in fact, many cases, that's the best that we can do is simplify an expression. I'd like you to add this to your notes that expressions need to be simplified. And let's emphasize, I'm going to go ahead and add a note here on the end, not solved. So what do I mean by that? Well, if I have an expression that looks something like this, like, let's make it 3x minus 2 times 5x plus 7. This guy, no matter how hard I try, I'm not going to find the value for x. There's not enough information here to tell me what x might be. So I'm not solving for x. The best I can hope for is to simplify this expression. And the way I would do that is I do a little distributive property, negative 2 times the 5x and negative 2 times the 7. That gets me 3x minus 10x minus 14. Then, of course, I combine like terms. Oh, and one thing, again, you might ask yourself is why is he, if he believes that we're not solving, why is he putting this equal sign in there? It's a very good question. Glad you asked. The reason why is because I'm trying to show that the expression that's written on top is equivalent to the next expression that I'm writing. And that's the only reason for putting down the equal signs. So anyways, then we'll combine like terms, negative 7x minus 14, and that's a simplified version of the expression on top. Notice how I put the number with the x in front of the just plain number. Okay, Another thing that I would like to add to this is sometimes we will use you'll see the word in a problem that says evaluate. So sometimes we evaluate expressions. So it's not always that you'll be given the direction to simplify, but sometimes we evaluate expressions. And let's see what that means. So just in case you're kind of curious about that, let's try a fun one. Let's make it really big. 2 times 5. Uh, uh, ooh, that's not the example I wanted to do. Let's go back. Let's try, this one will be fun as well. We're going to look at 1, where we go 140 minus 5 times 3 plus 7. One thing I want you to notice is that if you look at this guy, there's no variables. That means that if we simplify this, we will get a value. And that's where the term evaluate comes from, okay, that you can get a value from it. So let's try it. Let's go ahead and simplify. I wouldn't mind if you would try this on your own first before I get started. Why don't you pause the video, and then we'll check and see if you agree with what I come up with. Okay, let's see how I'm going to do it. So I'm going to, because of PEMDAS, I'm going to go in order of operations. I'm going to first distribute this -5. Well, ooh, never mind. I'm not going to distribute. I just realized because of PEMDAS, I got to do what's in parentheses first. So let's do 140 minus 5 times in parentheses. I have 3 plus 7, so that's 10. Now the next thing that I will do is multiply the 5 times the 10. Even before I do 140 minus 5. And the reason for that is because PEMDAS says multiply before you add or subtract. So this will be 140 minus 50. And in the end, oh, and let me make sure I'm putting my equal signs to show that each expression I'm writing is equivalent. And in the end, we end up getting 90. And that is our... that's the value that you get when you simplify this, or if you evaluate this expression, that's what you get, 90. Let's take a look at another variation of this. You could have something like this, where I give you some values. I might say something like, here's an expression, a plus b squared. And I might give you something like a equals 3 and b equals -2. And then I might ask you to evaluate. Now here, again, the reason why I say evaluate is because in the end we'll have a number. I'd like you to try this one on your own. See if you can get a value for a plus b squared when a is 3 and b is -2. And in a second, after you pause the video, I'll show you what I get. Okay, let's take a look. So I'm going to replace the a with 3, and I'm going to replace the b with -2. So plus -2. And then I'm going to square it. Now some of you might have jumped the gun a little bit, and you might have gone directly to 3 squared plus -2 squared. Be careful about that, because that's not the correct result. We'll go ahead and use PEMDAS, and if we add the two things in parentheses together, we get 1. And then when we square that, we still get 1. And so actually, let's go ahead and let's be a little consistent here. We'll use a different color. In the end, we still get 1, and so if you evaluate that expression, you should get 1. Now, if you tried to do 3 squared plus -2 squared, and you got 9 plus 4, which is 13, that's because of a misunderstanding about how we work with this power. This power does not mean square the a and the b. It would if they were multiplied, but not when they're added. And that's something you can ask me about in class, and we can firm that up to make sure that you really got that. Let's see here. Let's do one more just for fun. Okay, let's do a big one, and actually I'll write it out while you're not looking. Now I don't want to steal all the fun, so I will allow you to go ahead and get started on this one. If you want, you can write this down and then pause the video and or pause the video now and write it down and see if you can simplify this expression. Now again, I want to remind you, you are not going to find a value for x. You're not solving this. The only reason I write the equal sign here is because on the next line I am going to write a statement that is equivalent to this. There really is no I'll talk about equations in a bit, but this is not an equation. This is just an expression, needs to be simplified. Okay, so here I go. Hopefully you paused it and you already started on your own. So I'm going to distribute it first, so that'll get me 2 times 5x, 2 times negative 3, that's 10x minus 6. I'm also going to distribute this negative 7x. It's negative 7x times 2x, and it's negative 7x times 4. So that'll get me negative 14x squared, and then minus 28x. And again, let's go ahead and go to the next step. Oh, and as long as we're doing some stuff here, I would like to remind you that it'd be really great if you were writing out and explaining your steps. If you can justify why you're doing what you're doing, especially to your neighbor when you're working in groups, you're going to be a much more successful math student. And especially if you're debating and you can prove your point, it's really good. This first step that we did is we used the distributive property, or I'm just going to write we distribute. In the second step, oh, actually that's what we did to get to here. Okay, so next we will go and write some more stuff. Well, let's first of all, let's rearrange this stuff. I'm going to say 10x minus 28x. That is negative 18 x. I didn't really want that in front though. I got to put negative 14x squared out in front, so then minus 18x, and then finally minus 6. The goal is to put these guys in order, and the order is usually with the highest power variable, then the next highest power variable, then finally the constant at the end. So this is the correct order for a polynomial. And by the way, the coefficients here are negative 14, negative 18, and negative 6. Now that's about the best that we can do, so I'll go ahead and I'll box that. That is, hopefully that's what you got, the simplified expression. And by the way, let me write one last thing to justify why we did that. To get from this step to this step, we combined like terms. Combine like terms. There we go. All right, so hopefully that helped you out with understanding simplifying expressions. In a minute, we'll take a look at solving equations, hopefully.